Hello, this is example 4 of section 8.2. In a study of longevity in a village in Ecuador, 29 persons in a population of 99 were aged 65 or older. It is also known that 20% of the US population is 65 or over. Does it appear that the proportion of Ecuadorian villagers surviving to 65 and beyond exceeds that of the people in the US? So because it says proportion right here, that's how I know I'm going to do a 1 prop z test. Do a little mental check of the requirements of a 1 prop z test. Random sample, check. Does it meet the binomial condition requirements? So are there only 2 outcomes? Yes, you're either 65 and older or not. Fixed number of outcomes? Yes, 29. Independent? Yes, because we're talking about different people. People are independent of each other. And does the probability stay the same since they're independent? Yes. Next, are there at least 5 successes? Yes, there's 29. Are there at least 5 failures? Yes, there's 70. So we can do this. So the claim is that the proportion exceeds the US, so greater than 0.20. The null then will be p equals 0.20, and the alternative will be p greater than 0.20. So this is another right-tailed test. Yet again, alpha was not given, so we're going to use 0.05. Okay. Next, I need to calculate my test statistic, which means I need to know what p hat is first, which is 29 over 99. Then our test statistic is that number minus our null hypothesis, so 0.20, divided by the square root of 0.20 times 1 minus that, so 0.80, divided by n, which is 99. Plug that into our calculator. And we're getting 2.31. This one I'll do a p-value for. So remember to do a p-value. That's the probability of being more extreme than the test statistic. Since this is a right-tailed test, that means the probability that p is greater than 2.31. Sorry, not p, z is greater than 2.31. So I look 2.31 on my normal distribution chart. That gives me 0.9896. But on the chart, that's the probability of being less than 2.31. So to get the probability of greater than that, I go 1 minus that. So we get 0.0104. Now I take that value, compare it to alpha. Since my p-value is less than alpha, we reject the null hypothesis. Since we rejected the null hypothesis, there is enough evidence to support the claim that now here I'm going, just to make it a little shorter to write, I'm going to rewrite it so the Ecuadorian villagers live longer than Americans. Or you could have said, there's enough evidence to support the claim that the proportion of Accordion villagers surviving to 65 and beyond exceeds that of the people in the United States. Means the same thing. And that's it for example 4 of section 8.2.